you truly believe that safety is important in your work, at home, or anywhere else, there is no place for these two phrases, safety first and safety is our number one priority. To do a job safely, our goal is to complete it without accident or injury. But the slogans safety first and safety is our priority will not help us achieve this goal. The danger in making safety a priority rests within the reality that priorities get reshuffled throughout the day. When we're under pressure to complete a job, we may find that safety first can easily become safety second, safety third, or moved so far down the list that we end up taking ridiculous risks that result in accidents. Your employer is not in business to make you be safe or to keep you safe. There's no doubt that they want you to go home safe and healthy every day, but the company's priorities revolve around different goals, just as your goal is to make money in the form of a paycheck. Slogans like safety first and safety is our priority discourage personal responsibility because safety begins and ends with you. Is it reasonable to think that someone would hire you to do a job and then tell you that nothing is more important to them than your personal safety? Of course not. All sorts of jobs, ranging from easy and relatively safe to difficult and dangerous, are done by people who are willing to assume risk. It is true that your employer does not want you to get hurt. It's bad for business, it's bad for the customers, and it's bad for the bottom line. No one wants their employees to get hurt. Therefore, most workplaces have some safety policies and procedures, all with your safety in mind. But they cannot force you to make safety first or to make it the priority in everything you do. The employer isn't your parent and you're not a child. The key to safety is personal responsibility. Hazards and various degrees of risk from hazards are everywhere, and they cannot be completely eliminated. On the other hand, hazards can be known and they can be understood. Every task you do has to be approached with varying levels of hazard awareness. You can look for and understand the hazards in every job, or you can ignore them. Your job can be approached with care or with a lack of care for safety. All of that is going to be up to you. Don't rely on cute little phrases to make you safe. Rely on yourself. Remember, the key to safety is personal responsibility.
Personal Protective Equipment (PPE). Use of personal protective equipments (PPEs) to reduce the employee exposure to the hazards when engineering and administrative controls are not feasible or effective in reducing these exposures to acceptable levels. Mandatory PPE: safety helmet, hard hat. To protect workers against impact and penetration of falling, flying, and stationary objects. Safety shoe. Workers performing tasks which potentially expose them to extreme foot injury hazards, such as operating a ground temper or chipping concrete with a jackhammer, shall wear metal foot protectors. Safety goggles. To prevent employee eye exposure by requiring all workers and projects to enforce eye protection use. Impact-resistant safety glasses with side shields. Prescription lens safety glasses with side shields. Vented safety goggles. Non-vented safety goggles.
Program is to provide general information concerning the safety aspects of handling and storing atomized aluminum powder, aluminum flake, and aluminum paste products. Millions of pounds of these products are shipped, stored, and handled safely by thousands of workers around the world year after year without incident. However, under certain spontaneous conditions, aluminum powders, flakes, and pastes can present fire or even explosion hazards. Therefore, it is extremely important that all facilities using these products maintain a scrupulous housekeeping program and strictly follow the safety guidelines discussed in this program. The recommendations presented in this program have been compiled from information provided by the National Fire Protection Association, the American National Standards Institute, and the Aluminum Association, as well. A storage area is designated as an area where aluminum powder and paste products are kept in closed, sealed containers separate from production or processing areas. Storage should be in original sealed containers. All containers should be inspected upon receipt and regularly thereafter to ensure that there are no leaks or container failures which may expose the contents to moisture or other contamination. Containers open for removal of product should always be resealed immediately. Storage should be preferably in rooms of fire-resistive, non-combustible, or limited combustible construction. Aluminum powder or paste storage areas should be segregated from those sites where flammable liquids, oxidizers, combustible materials, or other materials that are incompatible with aluminum are stored. Stored containers should be stacked carefully to ensure stability. Ample aisle space should be provided between rows of stored containers to ensure ready access to those containers. Avoid exposure of the stored containers to water. Aluminum powder or paste, when it comes in contact with water, may result in a reaction which could generate significant heating of the powder or paste and also the generation of highly combustible hydrogen gas. Leaks in steam lines, water lines, radiator walls, floors, and roofs should be repaired promptly. Smoking and open flames are prohibited in areas where aluminum powders or pastes are stored. Containers of aluminum paste should be stored in areas where the temperature is maintained below the flash point of the paste solvent. An effective safe handling program focuses on good housekeeping and the control of potential ignition sources. Sources of ignition may include, but are not limited to, cutting torches, welding activities, smoking, grinding, and static electrical discharges. If maintenance activities are planned in an area where aluminum powder or paste are being handled or processed, all machinery, ductwork, and dust collectors must be shut down, emptied, and cleaned, and then all aluminum dust, powder, or paste removed from that area. An effective hot work program should be in place to control potential sources of ignition. Smoking is strictly prohibited in all areas where aluminum powder or paste is stored, handled, or processed. Great care should be taken to avoid the generation of airborne dust during the transfer of aluminum powder and paste products from one container to another. Powder and paste should be transferred from one container to another using non-sparking conductive metal scoops with as little agitation of the materials as possible. Handling must be slow and deliberate to keep dusting to a minimum. All containers must be bonded together and also grounded to minimize the possibility of unexpected static electric discharge. Where aluminum powder and paste are handled or processed, all electrical equipment and wiring must be suitable for areas where Group E conductive dusts are present and installed in accordance with the National Electric Code NFPA 70. All equipment used in the processing of aluminum powder and paste must be thoroughly grounded to eliminate hazardous static discharge. Non-conductive components of processing equipment, for example flexible rubber screen boots, must have an effective bond-to-ground in place. Information on proper bonding and grounding procedures may be found in the National Fire Protection Association's publication NFPA 77, Recommended Practice on Static Electricity. The interior of all processing equipment and ductwork must be inspected regularly for possible accumulations of fine aluminum powder, particularly at change of direction points, such as elbows and other areas where a dead spot may occur. Aluminum powder and paste should not be allowed to accumulate on rusty surfaces. If an impact should occur involving a tool or other object, an extremely hazardous thermite reaction may take place. The use of an inert gas such as nitrogen or argon to replace air, which reduces the level of oxygen to below that which will support combustion, increases the safety of many operations. This is particularly true in cases where it may be impossible to ensure that all sources of ignition have been eliminated. Since it is almost impossible to extinguish an active dry aluminum powder fire, solutions to the problem are focused on the control of these fires in the incipient stage. Aluminum powder fires are characterized by the emission of extremely bright light, very high heat, and the generation of large amounts of white smoke. Suppressing a metal powder fire should only be attempted by personnel who are trained in the special precautions required for fighting fires involving such combustible metals. In the interest of life safety, an assessment of the situation should be undertaken to determine if the fire can be safely fought with existing resources. It may be that the most prudent course of action would be to isolate the fire as much as possible and allow it to burn itself out. Professional or volunteer firefighters from the surrounding area cannot be expected to be trained for the specific fire and life hazards associated with aluminum powder and paste fires. Local firefighters, however, should be directed by the facility safety personnel for their own safety. Water must never be used to fight an aluminum powder or paste fire, since the water will react with hot aluminum powder to form highly explosive hydrogen gas. The force of the water hose stream may also suspend the aluminum powder and form a potentially explosive dust cloud. Fire extinguishers rated for Class A, B, or C fires also must not be used, since the extinguishing agent may react with the burning aluminum powder and instantaneously accelerate the fire. Halogenated extinguishing agents are also not used on aluminum powder or paste fires. If such extinguishers are present in an area where aluminum powder or paste is handled, they must be marked not for use on aluminum powder fires. Aluminum powder fires on reasonably flat surfaces may be controlled and isolated by blanketing the burning material with a Class D type dry extinguishing agent and then by wringing the burning material with dry sand. Long-handled shovels or scoops made of non-sparking material are to be used for the application of dry extinguishing agents. This should be done with great care to avoid disturbing the powder and forming a dust cloud, as even a minor dust cloud may explode violently. A properly blanketed fire will develop a hard crust of metal oxide, which ultimately eliminates enough oxygen to cause the fire to self-extinguish. After dispensing the extinguishing material, all personnel should leave the area, closing all doors which lead to the area, and then sealing them with sand or other dry granular non-combustible material. All fans and machinery, including dust collection systems, should be completely shut down. Drafts should be eliminated wherever possible. The aluminum powder may continue to burn under the crust without visible flames and therefore should not be disturbed until such time as it can be determined that the fire is completely out. Disturbing the crust may cause reignition of the fire. Flake aluminum powder has a lower density and a much greater surface area than atomized aluminum powder. Therefore, it tends to not only disperse and form dust clouds more easily, but also ignites more readily. Great care must be taken when attempting to extinguish a mass of burning flake powder so that the particles are disturbed as little as possible. Aluminum paste products consist of aluminum flake powders suspended in a high flash point combustible solvent. An aluminum paste fire typically begins as a solvent fire and can be fought using Class B extinguishing agents such as dry chemical, foam, or carbon dioxide. Once the solvent fire is extinguished, the residual powder may reignite due to localized heat or spontaneous heating. To avoid reignition, the residual material should be smothered with a Class D agent. At some point, the paste fire may begin to exhibit the characteristics of a powder fire, at which time it must be treated as such. Obviously, judgment must be used in determining whether Class B agents can be safely used on aluminum paste fires. If the Class B agent is applied carefully, it will be very evident if the fire is accelerated. At this point, the fire is considered to be a powder fire, and the use of Class B extinguishing agent should be discontinued, and a Class D agent, or dry inert granular material such as sand, used in the manner indicated for an aluminum powder fire.
Every year, more than 1,000 people in all walks of life are killed, and more than 30,000 are injured in electrical mishaps. Now, we're all familiar with the great things electricity can do for us. But to use it safely, it helps to know what it is and how it works. They can be in a portable cord like this, or in outlets. Ground fault circuit interrupters, called GFCIs, detect very small changes in current and almost instantly stop the flow of electricity. One of the most common electrical terms is voltage, which is the force that moves electrons in the current. 120 volts is found in typical wall outlets and in some industrial equipment and lighting. Most electrical fatalities involve 120 volt circuits. You also might work around equipment that uses higher voltages, such as 240, 277, or 480 volts. High voltage circuits such as these are especially dangerous. The amount of electrical current is measured in amperes, usually called amps. It's important to remember that the greatest danger is from the amount of electrical current, the amps. In fact, less than 1/10 of an amp can kill a person. There are two types of electrical current: alternating current, called AC, and direct current, called DC. Alternating current is produced at electrical generating plants and is distributed to our homes and businesses. It's called alternating current because the current rapidly alternates back and forth in a circuit. Direct current flows in only one direction. It's the type of current produced by batteries. Direct current can create hazards. For example, vehicle and forklift batteries can produce dangerous sparks capable of igniting gases and causing an explosion. Another important electrical term is ground. Objects are grounded if they're connected to the earth with a conductor. Electrical tools and equipment can be grounded through the ground prong on a cord. The ground prong is connected to a separate grounding wire inside the cord. If there were a short circuit, the surge of electricity would flow through the ground wire and into the earth, rather than into a person or equipment. Now, static electricity is an electrical charge that builds up in a variety of objects, ranging from storm clouds to people. Static electric discharges can range from a tiny spark with very little current to a bolt of lightning carrying several 100,000 amps of current and several 100 million volts. But even a tiny spark can be dangerous in work settings with explosion hazards and flammable liquids. For this reason, during the transfer of fuel or flammables, containers are first grounded with a bonding cable before transfer. This helps prevent the buildup of static electricity and the release of dangerous sparks. There are plenty of other electrical terms, but the information we've covered is an important step in protecting yourself from electrical mishaps. Staying alert for hazardous conditions in our surroundings is another way to protect ourselves from electrical mishaps. For example, watch out for loose, missing, or hot covers, switch plates, or outlets. Defective or exposed wiring and overloaded circuits are other common hazards. Report these conditions to your supervisor so they can be fixed. And if you find these situations at home, have them fixed. Other hazards, such as loose, exposed, or cracked wires, may be found in walls, ceilings, and crawl spaces. These spaces are often cramped and poorly lit, which just increases your risk of injury. To help detect any hazards, it's important to use good lighting in the work area. Personal protective equipment is also essential. If you're working above you, use safety goggles to protect against falling debris. Cutting into walls can also be dangerous due to the risk of cutting electrical wires. To locate hidden wires, you can review blueprints, as-built drawings, or use a circuit tracer. If you're operating a powered lift or a crane, or if you're carrying conductive materials, remember to check above you for hazards, such as overhead power sources. If you're going to be doing any work around electrical sources, remove conductive items such as watches, jewelry, and even metal belt buckles. Now let's look at an incident involving a potential electrical hazard that we find all around us: water. Not only was the man with the conduit distracted, the control panel had also been left open and unattended. Staying focused on your work, your surroundings, and your safety is your best protection. Finally, the wrong frame of mind can cause hazardous behavior, such as taking shortcuts and being inattentive. The right way? We should keep our attention focused on our work, avoid shortcuts, and make a commitment to work safely. Simple mistakes can result in tragic consequences when electricity is involved. For instance, several common yet serious mistakes contributed to that mishap. First of all, he didn't turn off the electricity. Next, he wasn't wearing any personal protective equipment. Also, he was using a tool that wasn't insulated, and he was using an aluminum ladder while performing work near a possible electrical source. Let's look at the right way for this job to be performed. Go to the source, turn off the power. Using a breaker lockout device will prevent the power from being accidentally turned on while you're working. In fact, there are many situations where regulations require that the power be locked out by a person authorized to perform lockout. Next, use your personal protective equipment. In this case, safety glasses with side shields. If you're working around potential electrical sources, there should be no metal in the glasses. Wearing leather or insulated gloves will give you added protection. Before you actually start work, use a circuit tracer or meter to verify that the power is on. Next, using insulated tools will help protect you from electric shock. Insulated tools are designed to protect against shock up to the voltage level shown on the tool. If you're using electric hand tools, double insulated tools will give you the greatest protection. Finally, if you're working near any potential electrical sources, it's best to use a fiberglass or wooden ladder. But make sure it's dry, clean, and unpainted. Now see if you notice the mistakes in this next scene. Several common mistakes contributed to this mishap. First of all, he had liquid in his work area while using an electrical tool. Whether it's water on the floor or in a cup, water and electricity have to be kept away from each other. Keep your work area dry and avoid bringing liquids into the area. Let's look at some other mistakes. Not only was the insulation on the extension cord damaged, but he was also using a cord that had the ground prong removed. Before starting work, select a high-quality extension cord that's in good condition, that's rated to handle the equipment being used, and has an intact ground prong. Select a cord that's been approved by an independent testing laboratory. Avoid using adapter plugs because they eliminate the proper ground that will protect you from shock. Using a cord with a built-in ground fault circuit interrupter will also protect you from shock. Another dangerous mistake is turning the power on and off by plugging and unplugging a cord. This can cause sparks, create a shock hazard, and damage the cord and outlet. We've seen how important it is for our safety that we prevent mistakes like the ones we've seen. But it can be just as important to know what to do if an electrical mishap occurs. Knowing what to do and what not to do if you come across an electrical mishap like this can mean the difference between life and death for the injured person and yourself. First of all, don't rush into the situation. You could be injured or killed. If the person is still being shocked, don't touch them. You could get shocked too. If you can, quickly shut off the power and call for emergency medical help.
There's been an accident in Warehouse B.
If you can't turn off the power, use a dry, clean, non-conducting object to push the person away. Then call for emergency help.
I'll go get some help.
If the person is no longer being shocked, call for emergency medical help immediately or get someone else to call. If possible, turn off the power source. Try to calm the person and keep them still until help arrives. Don't give them water, because it could cause a stroke. If they're bleeding, don't touch the blood. If you're the person being shocked and you can't let go, let your knees collapse. The weight of your body can pull you away from the source of the shock. Of course, the safety practices that we've talked about will protect us at home as well as on the job. No matter what job you're doing and whether you're on or off the job, it's important that you're qualified and authorized to do the work. If you have questions, check with your supervisor or hire a qualified electrician. Remember, most electrical fatalities involve 120-volt circuits, like we have in our homes. So give electricity the respect it deserves, both on and off the job. Your safety, the safety of your family, and the safety of your coworkers depends on it.
Hi, I'm Kay, and welcome to Welding 101. First, let's go over some rules. There is no messing around in the workroom. No running, crying, or hitting. Let's be professional. Secondly, always wear safety gear. Wear long jeans and long shirts at all times. There's no need to show off your muscles. Number 3, wearing a welding mask is very important. It protects your eyes from harmful lights, and without it, you could go blind, and that's just not cool. Don't ever weld without an advisor if you're not a certified welder. It could be harmful to you, and especially to those around you. Don't ever touch a welder tip after or while it is being used. It can melt your skin off, and that could cause permanent nerve damage.
There are three main reasons for the fire, like fuel, oxygen, and source of ignition. By removing any one from the fuel and oxygen, we can stop fire. Fire is categorized in 4 parts: Class A, Class B, Class C, and Class D. Class A, solid fire, that is, fire due to woods, clothes, rubber, and paper. Class B, fire due to flammable liquid. Class C, fire due to flammable gas like fire due to LPG. Class D, metal fire. Shut down the power when there is fire due to electricity. Then find out the category of fire A, B, C or D and extinguish accordingly. Method to operate fire cylinder. Read the labels and learn how to operate fire extinguisher. Pull the safety pin of the cylinder. Face the head of the hose of the cylinder towards the base of the flame. Press the hand lever. Keep on moving the hose left and the right on the surface of the fire until fire is extinguished. Call emergency immediately if fire is beyond your control. Special precaution to be kept during firefighting. Don't use water for extinguishing fire on electrical equipment. It may give electric shock. While using carbon dioxide cylinders, cylinder and hose become very cold, which may cause cold burn. Therefore, use it without touching metallic parts with hands. Hold hose also at the right places. Don't obstruct access to fire extinguishers. If you don't know firefighting, seek help immediately.
Here's an amazing statistic. More than 11% of forklifts in use today are involved in accidents every year, and more than 35,000 workers are killed or seriously injured, and another 65,000 workers sustain less serious injuries, all in forklift accidents each year. Accidents are caused by failure to follow simple safety rules, and here are 8 important rules to follow when operating a forklift. 1. Inspect your forklift before use. Be thorough. An inspection should be conducted daily and/or before beginning each shift. Defects or needs for repairs will indicate whether the machine is safe to operate. 2. The forklift operator must wear a seatbelt. No matter how often you get on or off the forklift during your shift, you must always wear a seatbelt. Almost half of fatalities in forklift accidents involve an operator who is thrown out or jumps out and then crushed by the heavy truck. In these cases, the driver was not wearing a seatbelt and was mousetrapped between the truck and the ground, causing massive trauma to the head or upper body. 3. Be aware of pedestrians. People working around forklifts often assume that the forklift operator can see them. Do not depend on pedestrians to avoid you. Make sure you look around while operating the machine. 4. Do not allow anyone to walk close by when operating a forklift. If you swerve, hit a bump or uneven surface, you may hit anyone nearby. Running into someone with a multi-ton machine is almost sure to severely injure or even kill them. 5. Slow down at intersections. You are approaching a blind spot and you have no idea who or what is just around the corner. Use your horn. 6. Make sure your driving surface is free of debris, spills, or anything else that could cause your machine to slide, bump, or become unbalanced. Slow down when approaching spills or other wet surfaces and avoid them if possible. 7. Never move more than a very short distance with a raised load. Avoid turning with a raised load and always move very slowly when the load is raised. Remember, the higher the load, the more unstable a forklift becomes. 8, and most important, always pay attention. Do not allow yourself to become distracted while operating a forklift. No earbuds, no reading, no use of phones. Always stay completely focused on the operation of the machine. Even a moment's distraction can be fatal. If you find your attention being diverted for any reason,
safety afforded by a ladder is often circumvented by misuse. Each year, over 160,000 people are injured as a result of falls from ladders due to not following safety precautions. Most of the injuries are cuts, bruises, and fractures, but more than 300 result in death. Making a mistake while using a stepladder can change or end your life. Properly following the techniques presented in this training will maximize your safety when using a stepladder. To begin, let's examine a stepladder. The stepladder is a self-supporting portable ladder that is non-adjustable in length with flat steps and a hinged design for ease of storage. The stepladder is intended for use by only one person performing work on a level surface. The stepladder requires level support for all 4 rails. If this worksite condition does not exist, the stepladder is not the correct product for the job. The parts comprising a stepladder include shoes. All 4 feet of fiberglass and aluminum stepladders are fitted with slip-resistant shoes. Shoes are optional on wood stepladders. Front and rear side rails. Steps. Spreaders or locking hinges. Optional bucket or pail shelf. Instruction and warning labels. And a top cap. Stepladders are manufactured in a variety of sizes, materials, and duty ratings. To select the right stepladder for a particular job, the following must be considered. Worksite environment. The worksite environment is the first factor in choosing the material from which the ladder is constructed. Ladder materials include wood, fiberglass, and aluminum. If the work to be done is near a source of electricity or requires the use of electrical power tools, an aluminum ladder should be rejected since aluminum is an electrical conductor. Electrical shock while working from a ladder can trigger a fall or cause your heart to stop, leading to serious injury or death. A clean, dry fiberglass or wood stepladder should be used. On the other hand, if there are no electrical power sources in the work area, an aluminum ladder may be lighter in weight and a satisfactory option. Next, length of the ladder must be considered. Stepladders range in size from 3 feet to 20 feet in length. Stepladders shorter than 3 feet are considered step stools and are not covered in this training module. It is unsafe to use a ladder that is too long or too short. Never try to extend your reach by standing on the top step, bucket shelf, or top cap of a stepladder. Doing so will increase the likelihood of losing your balance and falling from the ladder. The highest standing level for stepladders is the second step down from the top cap. This will be shown by a label on the ladder. The maximum work height is established by adding your height and reach to the highest standing level, the second step from the top. Do not step or stand higher than the second step down from the top. Finally, calculate the total weight the ladder is to support. Do this by adding your weight plus the weight of your clothing and any protective equipment, the weight of tools and supplies you will be carrying, and the weight of any tools and supplies to be stored on the ladder while working, for example, paint on a paint shelf. Compare the total weight to the duty rating of the ladder, which will be shown on a label on the ladder. There are 5 categories of ladder duty ratings. Type 1AA, Special Duty, supports a maximum of 375 pounds. Type 1A, Extra Heavy Duty, supports a maximum of 300 pounds. Type 1, Heavy Duty, supports a maximum of 250 pounds. Type 2, Medium Duty, supports a maximum of 225 pounds. Type 3, Light Duty, supports a maximum of 200 pounds. Do not assume that a longer ladder has a higher weight capacity. There is no relationship between ladder length and weight capacity. The key to ladder safety begins with the inspection of the worksite and of the ladder. To properly inspect and secure the worksite, check overhead for electrical hazards or obstructions. Clear any clutter from where the base of the ladder will be located. Be sure the surface on which the ladder is going to be placed is free of anything slippery, such as water, ice, or oil. Be aware of environmental conditions. Rain, snow, and ice increase slipping hazards. Wind may cause instability while carrying, moving, and using stepladders. Block off the area around the ladder to prevent being knocked from the ladder by people or equipment. If you are working around a corner, put up signs to warn others of your presence. Ladders must not be placed in front of closed doors. The door must be blocked open, locked, or guarded. Although highly durable, a ladder can become damaged by improper handling, transport, fire, or corrosion. A thorough inspection should be made at the time of purchase and before each use. Never use a damaged ladder. To begin, examine the ladder for loose, damaged, or missing parts. Start the inspection at the bottom of the ladder. Make sure the shoes are present and secure. Moving up the ladder, inspect the side rails for dents, cracks, or bends. Along the way, check each step. Ensure the step-to-rail connections are free from damage. Inspect all hardware and accessories. Make sure the spreader braces are not bent and work properly. Rivets, joints, nuts, and bolts must be tightly secured. All surfaces must be clean of oil, grease, and other slippery or sticky materials. When transporting a ladder to the worksite, caution must be used to avoid injuries, property damage, or damage to the ladder. If carrying a ladder solo, keep the front end slightly higher than the back end. Long ladders should always be carried by 2 people. When transporting by vehicle, secure both ends of the ladder and use care when loading and unloading from ladder racks. A ladder that does not pass inspection but is repairable should be tagged, taken out of service, and stored away from usable ladders until repaired. A ladder deemed not repairable, such as missing parts, having a damaged side rail or damaged step, should be destroyed and replaced. Absolutely never use a damaged ladder. A major cause of falls from ladders is improper setup. Using proper setup techniques will provide the ladder maximum stability and ensure your safety. To properly set up a stepladder, fully open and spread the stepladder so that all 4 legs rest on a firm, level surface, not on rocks or boards. Lock the stepladder's spreader in the fully open position. Never use a stepladder with the spreader in a closed or partially closed position. For example, never use a stepladder in the closed position and leaned against a wall. Stepladders are not designed for this type of use. Proper use of a stepladder will contribute significantly to your safety. Common factors contributing to falls from improper ladder use include haste, sudden movement, poor quality footwear, and lack of attention. Follow these guidelines for safety when using a stepladder. Before taking the first step onto the ladder, make sure you're in condition to do so. If you feel tired or dizzy or are prone to losing balance, stay off the ladder. Do not use a stepladder if you are impaired due to illness, drugs, alcohol, age, or physical handicap. Also, wear slip-resistant shoes with heavy soles to prevent foot fatigue. For maximum traction, clean your shoes of sticky or slick substances. Always read warning labels and instruction labels on the stepladder prior to use, or contact the equipment manufacturer with any questions. Continually face the ladder as you climb, work, or descend. Always keep 3 points of contact with the ladder when climbing, holding on with 2 hands.
Firstly, the work area should be clearly defined and barricaded off. Signage showing that scaffolding is being erected and is not yet safe for use should be displayed. Before you start, count and check off the various parts against a delivery docket or order to make sure that you have received the correct components. Here, a length of scaffold tube is being vertically lined up with the corner of the eaves. This aligns the scaffolding with the building. The parts for the first lift are laid out to roughly set up the positions of the sole plates. It's easier to place ledges and transoms between 2 sole plates than to measure. The sole plates are put into place. It's important to make sure the sole plates form a firm foundation. The sole plates are leveled. This often means that the ground underneath them needs to be excavated. use the base plate to compact down the sole plate. Now you need to check that the position of the sole plates and the base plates are correct. Careful preparation at this stage means a good foundation for the scaffold. You can see how the layout of the base lift is starting to take shape. The base plates should be adjusted to compensate for uneven ground. When making adjustments to the base plates, ensure you have scope for adjustment later. Now the first bay can be erected. Try to start at the highest point. Insert the base plates into the standards. Do this on both sides. Working as a team, the standards are lifted and the transom is inserted into the lowest V connectors. Notice on the right how the standard has been rotated so the highest V connectors go along the faces of the scaffold. The standards at the other end of the bay are then held in place and the ledges are attached. The final transom is inserted linking the standard. This bay is levelled using a spirit level. The level is adjusted using the base plate adjustment. This is completed on all four sides. The distance from the building is now checked and the bay is moved if required. If the bay needs to be moved, use a lever to move the structure rather than manually lifting it. Often the sole plates are not in the perfect place and will need to be adjusted. You then need to check that the bay is square. Do this by measuring the diagonal dimensions of the bay. These measurements should be taken from the inside of each standard. An alternative method to check the square of the bay is to see how the planks align with the transom. As you can see in this case, the bay needs to be adjusted. The pins and wedges are hammered into place. Then the upper transom and ledges are installed and fixed off. This is the first bay completed. We know this bay is level and square. The rest of the scaffold can be built off this first bay. The gap here allows for the hop-up brackets. This is one type of modular scaffolding. Other systems exist such as cup lock. The rest of the bays for the first lift are now constructed. These need to be levelled and aligned with the building as you are going. If broken or damaged components are found, like this bent wedge, they should be set aside and the hire company informed about the faulty equipment. This lift is planked out to form a working platform to make it easier to add the upper ledges and transoms. An access bay is then erected on the non-working face of the structure. A stairs system will be used inside the bay, providing easy access to the scaffold. The ground in this area is soft and a larger sole plate is used to distribute the load. The access bay is erected in the same order as the bays in the main run. The transom is attached to a new standard and to an existing standard on the main run. Level the base plates as you go. Because of the slope on this site, the base plates need to be adjusted to quite different levels. The upper transoms and ledges for the access bay are now assembled. At this stage, the first lift for all the bays of the main scaffolding are complete and now bracing needs to be added. The transverse braces are added to stop the scaffold distorting and swaying. As each lift is added, these usually form a zigzag pattern. The braces fit more easily if two people work together to install them, and the top is attached first. Transverse braces are added to the access bay as well. The stairs can now be lifted into place. These need to be carefully fitted over the transom. The area next to the stairs is then planked out. The return is constructed in the same way as the other bays. Check the level and square again. The ledges are rolled into place so the wedge drops into position. Transverse braces are added to the end of the return scaffold. The main run of the scaffold and the return are then tied together using tube scaffold and right-angle couplers. The couplers are normally attached to standards. Couplers are always installed so the tube is supported by the open clamp. The tube is placed in the coupler. The couplers are then tightened. Notice how the spanner is attached with a lanyard. When working at higher lifts, this means that if the scaff spanner falls out of the installer's hand, it will not drop and put other workers at risk. The extra length of the tube is overhanging on the inside of the scaffold. Because this is not a working platform, this doesn't create a risk. For additional strength and safety, check couplers can be used. The longitudinal braces are now added. Braces should be added to every fourth bay. This means the gap between the braces is 3 bays. The planks from the base working platform can now be transferred to the next lift to form the temporary working platform. The transom is lifted to provide headroom at the access point to the scaffold. The standards for the next level are now installed. Notice that when lifting, the scaffolder has a straight back. The standards are passed up the right way so that they fit over the existing standard. Transoms and ledges are put in place and act as temporary guardrails. Now all the transoms and ledges for the next lift are added, which will be the working platform. Components should not be stored on the working platform. The main run and return need to be tied together. Bracing is added to form the zigzag pattern. The stairs are now lifted into place. The stair handrails should be bolted into place using the holes provided in the handrails and stairs. The planks can now be lifted to the next working platform. As scaffold becomes higher, it often becomes impractical to lift parts by hand, so they need to be lifted using rope. Ledges and transoms are added 500 mm from the work surface to form mid-rails. Another set of ledges and transoms are added 1 meter from the work surface to form the final guardrail for the working platform. The tie between the return and the main run is now added. In this case, the extra length on the tube is made to hang out over the edge of the scaffold. Toe boards are installed by lifting the outer plank and rolling the toe board into place. Toe boards should be fixed to the standards using toe board clamps or wire. This needs to be completed on all ends. The steps up to the access bay are too high to be safe and comfortable. In this case, a step will be constructed from tube, couplers, and a wooden plank. The tubes to support the stair are attached to the standards under the planks using couplers. The tubes need to overhang enough to accommodate the planks that will form the step. The tube at the other side is set up in the same manner. The wooden plank is then added and held in place with check couplers. This step is now at a safe height. The stairs have been installed, however there is not enough head height. The stairs need to be repositioned. Now the problem has been solved. Platform brackets or hop-ups need to be installed to allow a working platform between the scaffold and the building. First, the brackets are installed at each end of the platform. The tie bar is then installed between the brackets. The planks are added to form the platform. The platform is now safe, and the guardrails and midrails can be removed. The scaffold is then checked. As a result of this checking, the need for a handrail to be installed at the top of the stairs became apparent. The final scaffold. The final inspection and scaffold tag needs to be completed. It's good practice for another licensed scaffolder who is not involved in the installation process to complete this inspection. If everything is okay, the final parts of the tag are completed. The scaffold tag then needs to be clearly displayed at the access